code for the team championship was inflated on the left with several messages, then several methods. And then in question 5, I brought everything together and added a little bit more detail. So it's quite a lot of reading. I leave it to the last. I don't think that's okay. Okay? Because you need to understand what you're doing this week, even though you've got organised on there. It will take you some time to do questions 4, 5, 6, and if you choose to do the rest. Okay? 1 and 2 you should do this week as a bare minimum. Okay? And my office hours this week have been moved to this evening and whenever I email them. But it's not Wednesday. It's tonight and tomorrow. Okay? So they're on the news item anyway, I'm telling you. Okay? So, let's look at unit testing. So, what does unit testing look like? Why do you bother? And why do you want to do it? Well, there are 2 reasons for doing unit testing. One, you can use it as part of your development strategy, to use it as a software engineering process to develop code. So you can say, these are the tests, now let me build some code to meet it. That's one way. Or you can say, I have a set of functionality, I want to build some code, and I want to check that it does what I think it should. So that's quite different. Here, I'm using the tests to drive what we're doing, okay, in a test-driven development. What I'm doing with the coursework for you is I'm giving you some tests so that when you've tested your code, you know that it's going to be okay. But I'm then also getting you to write some of your own so that you have practice in understanding how to do that if you were performing a testing role within a software engineering life cycle. Okay? So lots of placement students do lots of testing, and therefore it's important to know what it is. Okay? So you know whether it compiles because Eclipse will tell you, but you don't know if it's going to run under all of the extreme conditions that you might test your code with. You're not, if I've got 5 fields, then I'm not going to provide a test for all the possible combinations of all the possible 5 fields that I can have. I can't generate a test suite that's going to do that in a fairly easy way. So if I've got an integer between 1 and 100, a string, a double, and something else, to provide a comprehensive set, I've got to produce quite a lot of combinations of that lot. But only with respect to the way my code is going to operate. I need to produce a sample set of tests. So there are 2 views to be able to test my code. One, if I know what's going on inside it, I can write a test to know that, right, okay, if I give it values of indices that are less than 3, I know I'm going down this route. If I'm going to give it a test where the values are going to be greater than 4, I'm going to go down this route. But if I didn't know that my code handled that exception, then I wouldn't know to provide a test for 2 and to provide a test for 4. But with some knowledge of what's going on, I can provide a nice test that will cover each of these paths. But that requires me to know something about it. So the white box testing aims to provide a test to cover the paths and all the boundary cases that you're going to need. But it requires you to know something about the structure of the code that you have. So when I used to work for BAE, they had a test coverage metric, which meant that all paths in the code had to be tested. So 100% path coverage. So if our test suite didn't examine every path possible through the thing, then testing was not complete. So that's what was required for a defence piece of software. Right? So, but if I produced a set of tests for me, I probably wouldn't bother testing the exception cases, just to get a hang of what was going on. But white box testing gives you that idea. Whereas black box testing only makes you think about the interface and how you interact with the system. So all I know is that I can add numbers. So my black box test would say, add a number. It's not going to provide me any information about what kind of numbers I should use. It's much more looking at what functionality should I test. Well, I should test the add function. Whereas the white box one is saying, okay, test the add function so that you go down the good path and the bad path. It's a lot more detailed. So black box is, I've got these A to O requirements in my piece of software. I need tests to cover all of those in a fairly comprehensive way. But I'm doing it from the points of view of these requirements, rather than the points of view of the paths in the code. Okay? So, in terms of where we're at, what you want to do is make sure that your code captures the requirements. So, in the coursework I say the riders of a team the system shall display the riders of the team. So there needs to be a test method that creates a championship and allows me to execute the method that I've written for display. Because then I can have a test that checks whether I've displayed it. Okay, so that checks it against that piece of requirement. And then it says the system shall be able to display who's wearing the yellow jersey. So I need to be able to create a test which sets up a championship, sets up a bunch of riders, sets up a bunch of stage information that I can put in, calculate the yellow jersey, and then work out whether the yellow jersey is who I think it is. That's a test for that requirement. So your job is to look at the requirements and think, right, what do I need to do in order to build confidence that I've done that? That's what the job of testing is supposed to do. Okay? Now, when should you test? Well, you shouldn't wait and retrofit until the end. You should do it as you go along and when you've written a class. But if you're saying to someone, do you know what, I'd like you to write a class, you might actually write them the test suite like I've done with you. I've written you a test suite so that I know I'd like an object to be created with these 3 parameters, and then you've written me a class with a parameterized constructor so that it fits when I called it in the test. So in the way that we've done in the first coursework, I've test-driven developed the way you're going to provide the code. Because I've said, I want a class with 3 parameters. That's how you've decided how many parameters to have in your constructor, or how to have a default constructor. Okay. So we've been using it very much as a test-driven thing. So, on channel 23. If you're writing agile stuff, testing goes out the window pretty much. It's not a predominantly large phase. It's done quickly to get the phase out. So in agile software, you just produce lots of code, test a bit of it, get it out there, then fix it, test it quickly and get it out there. In the kind of software that I used to write, had really archaic life cycles, then the testing phase was flipping enormous. And it would take a long, long time, and you had to get it certified and signed off and everything. But testing in defence was also quite interesting, because not only did we have to test the software, but then we had to test the software being deployed in the box, and then the box being deployed on the aircraft. So that was all part of testing. So it was deployment testing in effect. So it was testing it in situ, in wherever the piece of software was going to be running. It wasn't just me on my PC. Okay? So for my placement year, I wrote C++ to measure the towed array floating around at the back of a submarine, picking up some sonar stuff. And I used to write C++ test suites for that. So that's what I did, and in the code in the system, I would write that on my machine. But then the whole testing phase of the project would then deploy my piece of software on the submarine, and then test it all, and then release it. Okay? So software testing isn't just about doing it in Eclipse. It is in this course, but not in general. Okay? So what you want to do is work out whether it's going to pass or whether it's going to fail. So, your job is to work out what kind of testing should I do at each phase. Well, if I'm writing a class, I'm at the top, I'm going to do a unit test. If I want to put some classes together, and then I want to group tests, then I'm called integration testing. If I shove everything together and I want to run system, then it's called system testing. And then you've got acceptance testing, which is doing it with some kind of user. In my case, it would also include sticking it on the ship. Okay? So the point is that the first one is the easiest one, because you're in control of the class, and then somebody comes along and they test it against the class that's been written and in a nice isolated environment. But we will sometimes find, and there's an example where if I've got a class and it is connected to another one through some kind of UML link, and I need to be able to test this class, and I've got a zero-to-many relationship here, which probably means that I've got some kind of list structure here representing this object. How do I unit test this now? Because I haven't got this, I've not written that yet. Okay? So unit testing needs still be done when I've got this, but not that class. So in the course, as part of what we're doing, we're going to look at how to produce unit tests for this, but when we've then provided a dummy, most basic implementation for this that we can get away with, so that we can do that unit testing. Okay? And that is something that I will expect in the exam. Okay? I will expect you to unit test with respect to a dummy implementation. Okay? So that's definitely something that you need to know. So unit testing isn't just about testing one of those. It's testing one of those in the context of where it sits in the rest of the system. If I want to test that as a unit test, I've got to provide a dummy implementation of this whilst I'm unit testing them. Okay? So, and to do that, we just provide skeleton Java classes in here in the test scenario of this thing. Okay, that's what we're going to do. The interesting thing about testing is that, well, as far as I can see, this is one of the motivating reasons why someone would want to become a chartered engineer. Defence projects can only be signed off by chartered engineers. I don't know if that is currently the case, but up until 2 years ago when I used to do those things, then that's certainly the case. So you have this level of certification. So that's a good reason why you would want to become a CEng, is that you can then finally sign off these things. Okay. So in Java, we want to compile it, we want to run it, and we want to do black box and white box testing. Okay. We're going to do white box because we know what we're doing, because we can look at the paths, also want to do black box because I've given you a list of requirements, and the tests and the coursework are done from both the white box point of view, plus also the functionality. And now we're on channel 23. When all the software is written, is too woolly. When all the software is written, could be all of these things. You don't wait until you've done all of those things before you can test your done bit. You should test as soon and as early as you can. Okay? That's really, really important. Because if you're not building up your code base from a correct footing all the way along, you're going to run into trouble. So when you have code, always try to grow it with structure in mind, but from a good working base. Okay? So you certainly shouldn't deploy software until it's all been tested and written and tested. That's a difficult approach, right? But testing itself should be done as early as possible. Robin was telling me yesterday, so he works, so my husband works for a software company, and they release insurance software. And they have deployment cycles that run via upgrades. But there are things you can't deploy before Christmas, because if something goes wrong with an car insurance company before Christmas, and somebody has lots of accidents before Christmas, then they can't issue changes in the system. So testing and deployment all go hand in hand, and they're all phased, and there are time periods of the year when some software cannot be deployed after it's been tested, because there'll be nobody there to fix it if the system doesn't work. So I didn't really think about it, but Christmas is a bad time of year to upgrade insurance software, apparently. So that's what I'm doing today. So, when would you do black box? What is it? Okie dokie. So, black box is from the user perspective. It's from the perspective of the functionality. It's from the perspective of the user interface, and therefore you want to look at it from how can I interact with the system. The boundaries is something more detailed, where you kind of know a little bit about what's going on in terms of the data structures of your system. So it's definitely not number 5. Boundaries doesn't mean it means what the system can and cannot do, but it's more to do with pushing the limits of the code that you've written. It's not a perspective thing. Try this one. Be more than one. The unusual situations is this thing down here. If I give it a value with an index which is 4 and I throw an exception, that's an unusual situation, an erroneous one that I want to avoid. Okay? And the boundary again is that I don't want to shove things in an array that goes outside its bounds, and therefore that's another example of boundaries. Let's turn it into something more concrete, because it's a bit more. So JUnit 4 is the harness that we're going to have. Today we're not particularly using anything exciting with JUnit 4 in the lab, but there is a package that comes with Google called Code Analytics Pro, and it is a harness that helps you work out the kind of combinations of inputs to test cases, and we'll be looking at that in software engineering next semester. So Code Analytics Pro is a really very nice package for making sure that your testing is more exhaustive than randomly selecting some stuff to test, which is more like the strategy that we're adopting in the current coursework. Okay? But Code Analytics Pro has been bought out by Google, that along with Window Builder Pro, which is their Swing automated front-end editor. Okay? And you'll be using both of those in software engineering. So, testing. Write a test. I've got a car class, and I have a constructor with a bunch of parameters. Right. So, the test says two things. First of all, create an object. So this test tests that the object is healthy. Every test class of a unit test needs to have a constructor test. This is a constructor test. It tests the constructor with some parameters, and then underneath it there is a bunch of assert equals to say whether the data in the object has been set correctly. Okay? Now, all of those things down there depend on what you've got in your class. Okay? So for my numbers example, I've got an add method. Okay? But I haven't got anything else. So, in my class I would say numbers, if my class was called numbers as well, capital N. Right? Capital N equals new numbers. And what I would hope is that in my class I would have a constructor, and I could call the default constructor, and the result of it is that I would have zeros in each of my entries. Okay? So, if I wrote that line of code in a test and gave the test a name, I don't know, let's call it, this should be that now, okay? Let me start with that. And I've got a test and I've created this. Do you think that's a good enough test? How to say, what's missing between the two?
Assert equals?
Assert equals. So the purpose of an assert equals is to be able to make calls. Whoa, sorry. Back. Turn my phone off. Estate agents. They never leave you alone. Right. So, if I've got this, in that class, I obviously had a lot of guesses. When I test the constructor, the important thing to do is to check that the data within the object has been set healthily, correctly, with respect to my constructor. But to do that, I need getters. But you should not do this. You should say, I'll have, well, I want to write a test now. Let me have a test that returns me the integer again. Oh, that's terrible. I should not do that, because what I've just done is I said, I've got a class, this blue one, and I want to test it. But I've not got enough, so I'll just add another one and leak the data structure. And break all encapsulation and return the pointer. Oh, that's terrible. That's the worst thing you should do. Okay? The best thing you should do is to say, do you think you've got the right class? Have you got enough methods in your interface? Is this a good API for arrays? No, because I can shove things in the array, but my class can't do anything else. So it's a really boring class. It doesn't do anything apart from stick things in an array and never let me see them again. Right? So it's not really helpful. So this is much better. I could say, I'll have a method called calculate total. And why am I picking these particular examples? Because they're exactly like your things to calculate the total time or total riders. You know, if you think I'm picking random examples, not ones related to your coursework, please take note, they are relevant to your coursework. Okay? So let's add some stuff. And I've got a method now, calculate, and the idea is that it's going to return the total of that array. Okay? So after construction, what's the total of my array? What do you think the total value of the elements should be?
0.
0. Because initially, through a default constructor, primitive values are assigned to 0. Therefore, I can write an assert equals 0, comma, n is my class, dot calculate total, bracket, bracket, that's it. Okay. Now what that says, create me an object, call me an assert statement, and use any other method in my class so that I can retrieve something sensible about my data. So, why am I saying this? It doesn't have to be getters all the time. It is any method that tells you something sensible about the data after construction. If there are no getters in your class, you should not add this one to leak your data structure for the purpose of testing. That's rubbish. This is good, that's bad. Okay.
How come some of your tests on the board you've got 0 before and after the method?
Okay. If the values of the return type of a method is a double, the precision with which the double is returned needs to be compared. Are you comparing precisely or with some degree of accuracy? The 0 at the end is the precision that we need to compare the two values. I'll come to that in a sec. Okay? So, it's just a test method, and the blue stuff is the test bit. The first thing you do is set the object, and then you check it against the behaviour that you want. And you use assert equals in order to do it. Okay? The assert equals has 2 or 3 parts to it. The first bit, this bit, is the expected, and this bit is the actual. Okay? I think I've got those the right way around. Yes. Okay? And then the last bit is whether we need to deal with doubles or not. So, the assert equals is only one kind of value. Okay? So, for example, in the middle statement there, we wanted to say that the engine was off initially. So we were saying that the result of that method was false. Okay, so we wanted to get the Boolean result and compare the results. We could equally have used things like assert true. If we wanted the engine to be on, we could have said something like car dot is engine on, and then used a different assert here. So in the lab today, you will see there are different kinds of assert statements that you can use. Assert equals is the one that compares values. Assert true, assert false are things that compare the Boolean results, if you want to, instead of using the assert true, false, comma, something or other. Okay? So the assertions are a way of saying, this is what I think the answers to be. Run your code and tell me whether it is that. Okay? And this is what you're going to write. And so these are the kinds of things that we want to have. Now, the last two are very important because if I created an object, then the object will not be null after creation, it will be valid. Therefore, I could have a line here which says, do this, then my next line could be assert that it's not null, i.e. a valid object. And then I could carry on going to other things. So some of the tests you write will include words like assert and null in it as well. Okay? So, the tests that you want to write are things that have got lots of different values and lots of different behaviours in them. So, in the code that we have, we can have one line of code that creates the object. So, that would be something like numbers n equals new blah blah blah. Then we could have an assert not null line to say, is the number okay? Then I could call my n.add with some stuff. Then I could do n.add with some stuff. Then I could do an assert. Then I could do another n.add with some stuff, which said that now, let me do 3 here. Created it, it's been created, I've added 3 things, so I filled it all up, I've asserted that my total is now, I've asserted that it's 60 through my calculate, then I've done another add, but now it should throw an exception. So, now, the at test will have some extra line of code up here so that when I run the 4th add, it will check the exception has been called. So that's a really comprehensive test. Create, check it's been created, add some stuff, check the healthiness of the calculations so that my calculate method works properly, add another one, white box the throw the exception, check that the exception's been thrown properly here. So that is the level of testing that I expect in the interesting methods within your coursework. Today, in the lab, you're going to do that on a couple of examples. Okay? So I need to get this lecture before the lab so that you can see the kind of stuff that you're going to cover today. We'll finish off the minutiae of setting up test scenarios in order to produce repeatable tests tomorrow, together with a workshop on inferences. Thank you.